So I'm David Brown. I am the director of the vFabric Applied Technology Group and one of the original legacy architects from the Gemstone acquisition. And now we're going to talk about some of the customer use cases, customers who have applied the GemFire technology and achieved some dramatic results and some dramatic business transformation in their applications. One of the first examples we'll talk about will be a sell-side investment bank, one of the largest sell-side investment banks in the world. And with a sell-side investment bank, you have an inventory of stocks that you're trying to sell to your customers. So you have two main things that you have to do as part of your application. You have to determine what your risk is, what your exposure is based on the stocks that you're holding, and you have to determine what price you're going to offer those stocks to your customers. So this bank wanted to run a real-time pricing and risk calculation. The state of the street is that back a few years, everybody did their risk calculation in a nightly batch run. So when you had your risk calculation and you started trading at the beginning of the day, the number that you generated over the night would start to drift away from the actual number that you would experience. So your risk would change as you did more trading. And with the acceleration of electronic trading and computer-based trading, this number started to become inaccurate very, very quickly. Another problem that complicated the situation were the Basel II and Basel III regulations. So these regulations are government regulations that require the banks to maintain a certain level of liquidity at all times. And given that they couldn't calculate their risk at any given time, it was very difficult to know how much liquidity to hold back at any given time. So as a result, they would create these large buffers of capital or overcompensate for the problem. And nothing bothered these investment banks more than having a bunch of liquidity sitting on the side that they couldn't play with. So the main driving force behind this company's decision to invent a new system was to go to real-time risk and pricing so they could reduce the size of this buffer capital and put more of their money in play. But it also was going to give them the ability to make better, more accurate decisions in their trades. So they built a system originally using a traditional relational database technology, one of the brand names out there. And they offered to have this company bring in the biggest system they could build. And they built a new system based on relational technology, and it could only handle 43 of their different products. Now, their products are the offerings or the stocks or the investments or the instruments that they're selling to their customers. The throughput through the system was so limited that they could only handle 43 products at a time. So the traders who were trading in those 43 products were very happy. The traders who were trading in the rest of the products weren't very happy. So they came to us and they built a new system based on top of GemFire. It took them about 9 to 12 months and a very small team of about 5 to 6 people to build this system and put it in production. Part of this new system also took the relational model and moved it to objects. If you think about the complex derivatives that they're trying to sell and the difference between them and the fact that they had these quants or these very strong mathematical people coming up with new and exotic different instruments to trade, those systems are all very different. So it's very difficult to model those instruments in a single relational database because they're so different. In objects, it's much more natural to using a technique called polymorphism to be able to handle different kinds of instruments but have them processed through the same system. So that's why they put that amount of time into developing the new system. But what they got in the end was a lot more speed. So on 8 CPUs of GemFire, they were able to reprice all 6,000 of their complex and exotic instruments in under 3 minutes. And in fact, they could reprice individual instruments in about 45 seconds. Their user trades or their user queries went from 20 minutes to under 5 seconds. The real reward from the system came on May the 6th, when we had in the U.S. something called the flash crash. And on that day, May the 6th, 2010, the Dow Jones dropped about 10% and then came back up about 80% of that drop within a zone of about 20 to 25 minutes. If you can think about what their new system allowed them to do, they could change their strategy and change their approach to their stocks for individual stocks every 45 seconds. Their competitors probably could do it once an hour. So this company made over $1 billion in profit off the backs of their competitors inside of that 22 minutes. Because they had this more agile system, because they were able to make more accurate, timely decisions. And this is kind of the theme that you want to look for in industry is where do I have opportunities where more timely, more real-time access to data will give me more timely decisions and give me more accurate results and give me better business results. Another case would be another large bank in their global foreign exchange trading systems. Exchange trading for currencies doesn't stop. There isn't really a trading day the way there is for stocks. So it's a 24-hour-a-day business. Now, this particular company had traders both in New York and in London. And they were using a system that used log shipping to move information about trades that happened in New York over to London. As a result, the traders in London, the data that they were seeing was minutes, if not half an hour old. So what they eventually realized was happening was, because the traders in London didn't have accurate information about what the traders in New York were doing, that the bank was actually making trades against itself, or doing arbitrage against itself, which is not a particularly good way to make money. It's a particularly good way to pay a lot of fees and actually not make any money. So they decided they need to improve their system. Now, they couldn't just replace their system with something fast, because speed wasn't the only consideration. This was their trade data. It had to be something that was as reliable, as highly available, as fault-tolerant, and as accurate in terms of data consistency as their previous system. So they wanted to get the faster speed. They had to keep the high availability. They also wanted some new features. If they're going to put the effort into building a new system, let's put in some things that people have wanted for years. And one of those things that they wanted was the ability to do pass the book. And with pass the book, they wanted the ability to take a group of trades, which is called a book, and be able to have it assigned to somewhere else. So when the trader is in London and who normally trades this book, when he's done, when he wants to go for a beer, with the press of a button, that book can be assigned to a trader in New York, and the data necessarily doesn't move because the data is in both places, but the ability, the right to update that data, and only that subset of data moves with that book. So that was a pretty key feature that this customer wanted. So they built this system, achieved all of these goals, and then after the fact, they kind of realized that they also saved a lot of money. So by replacing their previous system with GemFire, they were able to replace or get rid of, I think it was 2 Sybase systems in every region, with the exception of New York. They kept one Sybase system there to support legacy applications, reporting, and analytics kind of things. But around the world, and all their other sites around the world, they were able to get rid of the Sybase systems that were supporting this application. They got rid of messaging systems, both TIBCO Rendezvous, MQ Series. They got rid of some expensive file clustering system, Veritas, some expensive disk hardware, and some very expensive networking hardware that they needed to create basically a multicast link that went around the world. Their administration requirements dropped from 1.5 persons full-time to a half-person full-time, and they saved over $1 million in the licenses of this software that they replaced. So they got everything they wanted and saved money. Kind of a win-win. Another interesting company that isn't technically a financial services company, but they do everything that a financial services company does, is an online gambling system. Now, this one is situated in the UK, and in the UK, when they do bets, a lot of the bets are not bets based on the result of the game. They're what are called proposition bets, things that are happening in the middle of the game. So they're making bets and offering wagers to their clients in real time. Now, the way they interact with their clients is by putting banner ads on affiliate sites. So in this case, we see a website from a common kind of a sports entity, and we're looking at information about a cricket match that's in play. And here we see circled is a banner ad from our customer offering real-time odds about what's going on in that game, such as will there be a corner kick in the next 3 minutes, or will the current cricket bowler hit the wicket within the next 10 bowls. So this customer was in the business of providing these online bets, and similar to the previous one, they had an existing Oracle system. The Oracle system was limiting their throughput. So because they had limited throughput, they lost the ability to sign up new affiliates. By not having new affiliates, they couldn't reach out and get more customers. They couldn't add new products, and the products to them are new games or new wagers. And that was going to kill the business in a short order, because if they didn't come up with a new game, somebody else would, and they'd lose all of their customers. Their existing system limited the performance, and as a result, it slowed down those banner ads on the pages, and their existing affiliates, their partners that they'd worked so hard to get and were the core to their business, were threatening to take them off of their websites because they were causing a poorer user experience to the affiliates' web users. And because they didn't have any extra throughput, they couldn't perform any additional complex calculations on the back end. So as a result, they're kind of sticking a wet finger in the wind in making their wagers, instead of using complex software to make the best and most efficient wager. So they're kind of hoping they'd make a profit, which is not really a great way to run a business. So having realized all their problems, they came to us, built a new system based on top of GemFire. The new system met all their performance goals. It was delivering 2,500 banner ads per second. And that seems like a fairly low number for financial services, but if you think of all the things that banner ad has to do, it has to take into consideration what site did that request come from? Who's logged into that site? What are the agreements we have with that affiliate? What's going on in the particular game? What's happened recently in that game? What wager do we want to offer? It's a lot of processing to happen in that site. Now, 2,500 was their target. It was by no means the limitation of the system, because this customer actually did sophisticated testing up front to demonstrate that they could scale their system up multiple times and get linear scalability, that with the GemFire system that they built, they were nowhere near the limit of their functionality, so they knew they had room to grow their business. And it improved the performance on their affiliate sites, so their affiliates were now happy with them. They weren't complaining they were slowing down the sites, and it cost less. Now, this use case is an online retail financial trading system. It's a well-known brand name in a large industrialized country. And in this country, the culture of this country is that in the free time, people like to trade foreign exchange. Here in the U.S., we play on Facebook. In this company, they trade foreign currencies. Housewives at home spend their days trading foreign currencies. So this system is actually considered social infrastructure, not social media, but is considered social infrastructure in this company, so that if the delays are exceeding the SLAs, which I believe are a few seconds, then it's going to show up in the newspaper the next day. So this is a fairly significant system. So in this system, the customer used GemFire to provide much faster performance to very specialized customer web pages. So if you can think of going in and logging into your system and looking at your portfolio and doing analysis of different stocks and things, and then deciding to make trades, and all the online advisors that are in those kinds of systems, there's some very sophisticated web pages. In order to get those web pages to build quickly, they wanted to design very specialized, denormalized data objects for each page. And those data objects had to be populated with the real customer information. So if you can look at this diagram here, we see the web browser making a request to the app server for a page. The app server would then come down to GemFire and say, give me the specialized object for that page. Now, if it didn't exist, if it hadn't been built before, code would run inside GemFire, and this is kind of one of the key capabilities of GemFire, is that you can execute behavior inside of the database so that it's running very, very quickly. Code that was running inside of GemFire would build that denormalized view from the customer domain data and from the customer or from their master reference data. So it would assemble this specialized object as requested by that page. But then it would cache it both at the server level and up at the app server level, so that if the customer came back to that page and nothing had changed, then they would already have that object built and the customer would get an even better, faster experience. Now, caching is really great, but caching implies that you can hold on to an old value for a period of time, and it assumes that the application can tolerate the fact that that data might be stale. And that's not the case when we're talking about financial transactions. People want to see the latest up-to-date system, or the latest up-to-date numbers. So one of the key things about this architecture was that they had these change harvesters that were going out and looking for updates running off of triggers basically in their legacy database. And those triggers would update data inside of GemFire, and using internal GemFire mechanisms, an update to a customer record or customer portfolio would automatically cause an invalidation of any cache data that was built that was based on top of that domain data. So that if the end user came back and requested that page and something had been changed, the invalidation would mean they wouldn't hit a cached value. It would come back to the server and build a new version of that object that would contain the absolute accurate up-to-date value. So this system also went through some of the most rigorous testing I've ever seen of any software system because of the nature of the people that built it. It was very rigorously retested in order, again, to support the SLAs that if anything ever did go wrong, they and their names and their families' names were going to be on the newspapers the next day. So in another retail banking use case, this customer did a test where they would take some COBOL code that was running a nightly batch job, and this was a customer account reconciliation batch job, things that a lot of retail banks do. And the existing batch job was running on mainframe systems, and it was taking 2 hours to complete. So the first thing they did was they did an analysis of that 2 hours to determine why was it taking 2 hours. And if you look at the slide here, it shows you that 3/4 of that time was waiting for an available CPU. Well, everybody knows that mainframe CPUs are very expensive. So that means that the code spent most of its time waiting for an expensive resource. So one of the things that GemFire can particularly do is help you to apply a problem like this, like a batch run, and apply it across a large quantity of inexpensive, modern, highly efficient CPUs. So this is what the customer did. They took their COBOL code, they ran it through a compiler that allowed them to run it on top of Linux, and they modified just the data access layer of the code, so the piece of the code that went out to get data. They changed it so that instead of going to, I believe it was an ISAM file, they would talk to GemFire, which is a fairly easy transition to make. And so now the COBOL code was running on 25 Linux COTS servers, or common off-the-shelf servers, and that batch job now ran in less than a minute. And of that minute, we analyzed the time that it was still spending 93% of its time waiting for network now. So we moved the bottleneck, but the major thing was we'd gone from a 2-hour batch job to a 1-hour batch job. Okay? So who cares running that we can now move this thing faster? Well, a lot of people care. A, we can save money on the mainframe. We can reduce the number of mainframes. We can run on cheaper, modern, more scalable hardware. We can get away from the problem of, what's it called? I think the green zone is what they're calling it, where as your batch jobs get more and more complex, and as this amount of data that you have to process in a given night grows, the length of time it takes to calculate those batches increases and increases. And many companies are now at the point where those batch runs don't really have any space left. That they have to run complete, and they have to run accurately. Otherwise, they're not going to run by the time the next trading day starts or the time the next business day starts. So the fact that we can run it that much faster means that we can afford for something to go wrong. Now, nothing goes wrong in the GemFire software, of course, but things could go wrong. And if you they go wrong, you're going to know a minute later, and you can run it again after you fix the problem, right? And now that we've got more time, we can now do, just kind of like the previous case, we can now do new things that we couldn't do before. Add in new features, fraud detection, more regulatory compliance, upselling opportunities. We can add these things to our business that we didn't do before. And when you move from a long-running batch job to a short-running batch job, you are right on the line of being real-time processing. If the batch takes less than a few minutes or is very, very quick, you are now in a realm where you're doing things in real time, and you can make real-time decisions based on the results of those batch jobs. So why is it that GemFire improves system performance? Why are people attracted to it? This is kind of the topic of a longer conversation, a more technical conversation that we're not going to get into here. But at a very high level, GemFire was designed from the ground up by throwing out some of the sacred cows, actually some of the ways that things have been done in relational engines for years, turning them on its head, and designing a highly reliable, highly consistent database that was designed for OLTP. It is memory-based, so it gets the performance of memory, yet it has still got the capability of having disk backup, disk reliability, so that you can perform things like online backups and restores and have 100% guaranteed faith that the fact that it's never going to lose a piece of data or return the wrong piece of data. In difference to some of the new NoSQL systems that are out there, GemFire is completely data consistent. It is designed for business applications as opposed to social media applications. Nobody cares if you miss a particular Facebook post. Well, mine are pretty cool and my folks care, but for the most part, nobody cares if you miss a Facebook post. But everybody's going to care if you miss a trade. And that's where GemFire is designed, is to handle those high-level businesses, or those tier 1 business cases.